Hello, and welcome back for the extra part of 10.2. So these are just going to be some extra problems for 10.2 that just help us solidify what we did in class. So I'm actually starting with example 8, where we're kind of going over the grouped data again. So it says the data is from a random sample of 50 births taken from a 2007 North Carolina birth registry. The variable is weight in pounds gained by the mother during pregnancy. Use 10 intervals starting with 0 to 4, inclusive, meaning 0 and 4 are included in that category. 5 and 9 are included in this category. So I want you to go with 0 to 4, so I went ahead and made these for your table. So the width between classes is 5. It has just been by accident that that's been the width for the both examples that we did today in lesson 10.2. So it won't always work out that way. But we are going to find the midpoint first because it's asking us to find the mode, the median, and the mean. So the mode, we're going to look at the mode class once we get this filled out. And the median, we can look at once we have the frequencies in as well. So we're going to go ahead and put in the first midpoint. So the first midpoint is 0 plus 4 divided by 2, and that equals 2. And then we're going to have 5 plus 9 divided by 2, which is 7. So it's very similar to the last problem, just by happenstance. So the width is 5. So we're going to say 2 plus 5 is 7. 7 plus 5 is 12. And so likewise, we will get these as our midpoints, filling them out. And then the frequencies, I'm going to look to see what numbers fall into the 0 to 4 category. So we have, let's see here, 0 is 1. And it looks like that's the only one. So we have 1 in that category. And then there are 4 observations that are in the 5 to 9. So 8, 5, 5, and 7. So there's 4. And then there's 4. I'm going to go ahead and count these up for you. 3, 5, 8, 9, 8, 3, and 5. And they told us there were 50 births that they sampled. And so we know that this should total 50. And so the modal class is the class that has the highest frequency. And that would be this class right here. So the modal class is the class of 30 to 34 because they have the highest frequency. And then the median is going by, if we have 50 data points, it's going to be the average of number 25 and number 26 divided by 2. And so that means it's somewhere in here. So if we know that there are 1, 4 is 5, 4 is 9, 12, 17, 25. So we know that points 25 is in this range, and then point 26 is in the next range. So there is a 29 in this 25 to 29. So that's one of them. So 29 plus in the next range of 30 to 34, I think there is a 30. So that's going to be the next data point. Divided by 2 is 29.5 is the median. And then the mean is a grouped mean, a weighted mean. So just like we did in example 7. So that to find a grouped mean, we're going to take and multiply the midpoints times the frequencies. So this would be 2, 28, 48, 51, so on and so forth. This would be 235. But we're going to do this in Desmos. So let's go ahead and open up your Desmos. And here we are, and we're going to open up the mother's weight gain. And there it is. I put the midpoints in my X column and the frequencies in my Y column. And the X column are the weights gained by the mother, the midpoints of those. And then our frequencies are in Y. And so we're going to do the total of that product of X5, Y5 divided by the total in Y5, which is our number of mothers. So we end up getting a mean of 28. So our grouped mean is 28. So they're very close together. So we might want to know, what is the best way to decide what is our best measure of center? How do I know if the median is the best one I should choose or the mean? So in a perfectly symmetrical distribution, one that looks like this, where if you cut it in half, it was symmetric on both sides, the mean and the median are the same. And when we say the same, we're saying approximately equal. They most likely will not exactly equal, but they'll be approximate. In a distribution where the mean is greater than the median, notice that I'm putting the mean on the left and the median on the right. And I remember to do that because MEA is alphabetically before MED. So that helps me remember. If I always do it this way, then we can always use this rule of thumb. If the mean is greater than the median, we will say our data is skewed to the right because our arrow is pointing to the right. And this would look like some kind of a data set like this, where it's going to be thinner out here. Now, if our mean is less than the median, we're going to say that our data is skewed left. So it might look something like this. So let's look at, we have a couple more data sets to give us practice looking at the big picture here. So first we have for Susan Dean's spring pre-calculus class, scores for the first exam were as follows. And you can see from the Desmos link, I put this in Desmos. The mode we have to calculate by hand. And if you look at the ones that have multiples, it looks like 94 had the most. It has 4 observations. And then when we put the data in, I'm going to show you here in Desmos. When we put the data in here, the mean is, the median is 73 and the mean is 73.516. And they're very close together, actually. And so because they are approximately equal, we're going to say that our distribution is symmetric. And so we would choose the mean. Whenever your data is symmetric, we're going to choose the mean as your best measure of center. Okay. Then let's look at a new example. This example is scores, total score made by the Park City basketball team in the last 30 games. Again, we're going to look at this data on Desmos. Finding the mode, it looks like 47 is double, 32, but it looks like 48 has 3 occurrences and 52 has 3 occurrences. So this is bimodal with 48 and 52. And if we were to find the median and mean, we'll do that in Desmos. And so we're going to go ahead and look at the scores. The scores in Desmos here, if we look at the mean and the median, it looks like the mean is 47.24. And the median is 48. And so when we look at this on our paper, it looks like they are symmetric again. fairly close together. So we would say that this data set is symmetric. So let's go back to the data that we looked at, the electric data, the residents in a community in 2007, actually. So when we put this data in, we're going to find the mode, the median, and the mean. And it looks like there are multiple 50s. And then it also looks like there are multiple 80s. There's an 80, 80, and 80. So it looks like this is bimodal as well. So let's go ahead and look at the data in Desmos. Electric bills. And there is our mean and our median. So the mean is 158.33 and the median is 120. And if we look at these in comparison, we can most definitely see that the mean is larger than the median, significantly enough to say that it's skewed right data. And hopefully this gives you good practice putting it all together so far for chapter 10.1 and 10.2. If you have any questions, please reach out to me.